The most common question we get in our developer portal is, how do I decrease the latency of my voice agent? And my answer is always the same. You can't decrease anything until you understand exactly which aspects of your pipeline are contributing to the latency. So if you look at the typical pipeline of a voice agent, the user is speaking into the microphone, you're sending the audio to a speech-to-text provider, you're determining when the user finishes talking, when it's the end of their turn, when you want the agent's turn to start. You're crafting your response within the LLM. It's taking the user's input. Maybe you're doing external calls to APIs or databases or something. But at the end of all of that reasoning, you have some response from the LLM in text, which you then feed into the text-to-speech to get speech output, which you send back to the user's speaker in form of audio. Now, the user's perception of the latency will be from when they finish talking over here somewhere, all the way to when they first hear the agent start speaking back to them. So there's a lot of things in that blue line that comprise it. There's, first of all, the time it takes to determine that the user's finished talking based on when they actually finish talking, at the end of their turn. There's going to be some time for the LLM to do its work. That's going to be the time to first token. And then there's going to be the TTS, so that's your time to first byte. And finally, the network hop back from the agent where the TTS lives out to the device speaker. Now, there are other slight, very small sources of latency in this, but these are the big four that you want to start to address if you're looking to address your overall latency. Now, this is pipeline. You do also have a real-time model that you may have deployed. The latency expectation of the user is going to be the same. It's going to be from when they finish talking, actually it should be over here, we've determined it's the end of their turn, all the way to when they first start hearing the agent's response. But a lot of what I'm going to cover in this video will be equally applicable to both pipeline and real-time model. The obvious question, though, is we understand what might cause latency, but how do we measure it? And the best way to do that is with Agent Observability. So let me show you that. So what you're seeing here is a short session between myself and a basic agent, just comprises of a few turns and a tool call. You see, you have all of the information that I just spoke about. You have the overall end-to-end latency. You have the time to first byte from the TTS, the time to first token, and then in the user span here, the time in between when the user actually finished talking and when we determined it was the end of their turn. Now, bear in mind, this is the agent's view of the overall session. This is like agent observability, after all. So you don't get things like the SIP delay or the time it takes to get the audio from the agent to the end user. But in all honesty, the figures you're seeing here will be the largest contributors almost certainly to your overall latency. So this is the important view. As well as the transcript view, you can also view this whole session as a trace. So again, you have the same figures in the user turn, the end of turn delay, as well as the time to first token down here somewhere, and time to first byte is in here. Also have the end-to-end latency in the agent turn. And this really helps you dig in to understand, like, this is really good. End-to-end latency 1.24, that's good. That sounds like human speech. However, over here, you've got an end of turn of 2.8, I noticed when I was going through this. And you think, well, that was when I made my tool call. Is that because I was making an external API access? Well, no. This REST API call was 56 milliseconds. What was actually happening, and it's clear on this trace, is there were two agent turns, and that's why you saw the end-to-end latency was about double when we only had a single agent turn earlier on. So this helps you understand which aspects are contributing to your latency, but I still haven't covered what you can do when you know what's causing latency. So let's go back to the other diagram and I'll explain that in a little bit more detail. I needed to create a new diagram. That last one just wasn't cutting it to show everything you could tweak in terms of latency on a single diagram. The first and most important thing, though, that you should consider if you want to reduce latency is the geography. Like, where is everything physically located in your overall agent architecture? So I'll just go through like the previous example again, but in a bit more detail of thinking where everything is. So your user exists somewhere in the world. They will be connecting to the LiveKit cloud, most likely, or maybe they're connecting to a LiveKit server, but let's assume they're connecting to LiveKit cloud through the LiveKit SDK to one of our global endpoints. So it doesn't matter where they are in the world, they've connected to LiveKit cloud, but then the audio is then routed to your agent. So when you deployed your agent, you took a specific decision where to deploy that agent to. You either deployed it to LiveKit Cloud, and you would have chosen EU, North America, or Asia currently, or you might be choosing to self-host your agent. Absolutely fine, but your agent is hosted in one specific place physically. Within your agent, so the audio has then been routed globally to your agent. Okay, that's good. Then it gets to the individual speech-to-text, LLM, text-to-speech nodes. This is where most of the network hops happen, in between these providers and those provider models. So within like STT, you get multiple hops just to determine the text of what the user said. And then within the LLM, you again get multiple hops back out to that LLM model. Probably also includes multiple tool calls at this stage. So be aware physically where your external databases are, where your external REST APIs are potentially, where your external models are being hosted by your providers. That's something your provider can tell you. And then finally, obviously, the same is true of the TTS, multiple hops to the model before a single hop back out to the user. All of which is to say, the most important thing you should consider when you're trying to reduce latency is to make sure that the models that you're using are co-hosted in a similar region to where you've put your agent. Where the user is doesn't tend to matter as much, although obviously if your users are at opposite ends of the globe, then you will encounter latency from that point of view. But for most use cases, the location of the user is less important than the location of the agent. And then similarly, many use cases involve LiveKit SIP. Make sure that whichever external SIP trunking provider you're using, that's going to be hosted somewhere physically. LiveKit SIP, you can choose the regional endpoint of LiveKit SIP to connect to. So make sure you're connecting to a sensible endpoint, and that is co-located with the whatever external trunk you're selecting. Or if you're using LiveKit phone numbers, at the time of speaking, they're only available in the US. So this will be a US endpoint, but in time that will change. Another thing to consider. So that's the most important thing, physical location of your models. The second most important thing you should consider is which models are you using. I think most voice agent developers will always try and use the latest models, if nothing else, because the latest models are the most capable. You want to be seen as keeping up with your competition, but they're not always the fastest. Even when models purport to be the fastest, it would be a good idea to actually test those models in production against your use cases, against your scenarios, your prompts, just to make sure that you're happy with the performance of those new models versus the performance you were seeing with your older models. Just to be clear, it is always good to use newer models. You want to be performant, you want to keep up with your competition, but you don't want to do so at the expense of incurring excessive additional latency. And then thinking just a little bit more closely about the LLM, things you can set there. Obviously, the LLM has access to make tool calls. I have seen rare instances where some LLM models will make an excessive number of tool calls unnecessarily. So just make sure you cap that. Normally 3. There's a setting that you can set on the LLM. So cap that to say 3 calls within a single agent turn. If you do expect a turn to take a long time, the LLM needs to do a lot of thinking. It's doing a lot of lookup, reasoning. Just give some feedback back to your user. Maybe play some thinking sounds or have a separate agent talking to the user whilst it's doing that research in the background. We've got examples that show that. Another thing that's turned on by default, I believe, is preemptive generation. So as the user is speaking and we're converting that into text, we are starting the LLM reasoning even before the user's turn is finished. That can reduce latency, but the caveat there, and I think a lot of people will ignore the caveat, but if the context of what the user is saying changes before they finish talking, then the LLM has to throw away its entire turn and sort of regenerate its whole response. The example I normally use is if the user asks for the population of Paris, the LLM can probably start figuring out the population of Paris, France, but if they then add Illinois or Texas on the end of that question, then the LLM has to throw away its Paris reasoning and start working out the population of those other cities. And then finally, as your conversation with the agent grows, beyond maybe a few minutes, the conversation, the context window extends, the prompts get longer, you do tend to notice that LLMs are delayed in their response. Doesn't affect most voice agent use cases. Like I said, it's only the longer running use cases, but it's just something to bear in mind, the context size as the conversation continues. Also on this diagram, I put avatars. Like, you've obviously taken a conscious decision as a developer to use avatars. They're great. They bring the whole voice agent experience to life, literally. But bear in mind that it takes time to render those video frames, and the frames need to be rendered in line with the spoken speech. And so like that does introduce some amount of delay. So you have to take the hit there. But the only real thing you can do is to choose maybe a different avatar provider. If your current provider is too slow, it's not going to be the only consideration, because obviously you're also considering the capabilities of your avatar and the price of your avatar as well. But just include latency of the avatar as well as everything else that you're considering when choosing or maybe moving to a new avatar provider. The other thing to consider is many of these providers, the STT, LLM, TTS, real-time model providers, will all have individual settings that you can tweak, and some of those settings will have an impact on latency. Maybe there's a delay setting in there, or a ability to choose which pre-built tools are used for some of the LLMs. In general, those settings tend to be set as default to be a good trade-off between performance of the provider and the latency, but it's worth being aware that maybe there's some settings in there that you can tweak to have a slight effect on your overall latency. When looking at the turn taking, a lot of developers I've seen adjust the minimum endpointing delay. I think it's set to 0.5 by default, so that would be contributing to the end of turn detection that I was talking about earlier on. I've seen that set as low as 0.3. That can be a little bit aggressive, like the agent will be more likely to interrupt the user in that case, but depending on your use case, depending on the sort of users that use your system, maybe that would be appropriate for yourself. And then finally, if you are planning on using a real-time model in conjunction with what they call a half cascade pipeline, like maybe you're using real-time for LLM and TTS, but you want a dedicated speech-to-text node because you need to have transcription, or you want full control of your output voice, so you're using real time for speech to text and LLM, but you're using a dedicated separate text to speech node. Very real use cases, have their place, but just bear in mind that will impact your latency, because the latency will be essentially the worst of both worlds. So you're not getting the potential benefits of real time if you use a half cascade model. But other than that, I've put all of the information in this video, as well as a little bit of extra stuff, in a dedicated blog. I'll put the link down below. If you want to have any discussions with other developers about new models or existing models or problems, then swing by our community at community.livekit.io, or of course in the YouTube comments section down below. Other than that, I've been Darren, and thank you very much for watching. If you like this video, please do like and subscribe.